All right, this is my number 4. This one has a really small set of directions because I could not zoom it in anymore, but I'm going to read that relevant information to you and we're going to draw a Venn diagram to represent this situation. That's always helpful when you have intersections of different subsets, is to draw a picture. It says a computer consulting firm presently has bids out on 3 projects. So A sub I is going to be the awarded projects 1, 2, or 3. So they're either awarding money to 1, 2, or 3 essentially, or combinations of those. The probability that A1, which means we award it to project 1, is 0.22. Probability that it gets awarded to project 2 is 25% or 0.25. Probability that it gets awarded to project 3 is 0.28. Probability that we award to A1 intersect A2, so both of those projects at the same time, is 0.15. A1 and A3 is 0.05. A2 and A3 is 0.05, and all 3 projects would be 0.01. Okay, so we're going to be using the picture to help us answer the questions, especially the numerical parts. So this is kind of your whole universe, or S. Sometimes U is the universal set for universe. Sometimes they use that little squiggly S that we saw up in a different example. I think it was problem number 1. So it just depends on what textbook is using. But essentially, you draw your subsets inside. Got our A1 with the assumption, of course, that we have these overlapping parts. That's our A2. And that middle piece right there is going to be the overlap of all 3. And notice there is this empty space around the circles. That is the probability that things are not in any of those. So in other words, no awards for any of those. So let's start with the intersection. You always want to start with the innermost piece and work your way out. So the intersection of all 3 is 0.01. We're going to put that right there. Now, 2 intersect 3 is 0.05. So I have to show you this, and I'm going to use just kind of some color to highlight. 2 union 3 is not just that little piece out here. It's the 0.01 as well. It kind of looks like an eyeball. Try not to overlap the other pieces. That didn't go so well. Let me redraw that last part. All right, my computer mouse thing is a little fidgety with the highlighting. Okay, so that whole little eyeball kind of thing, I kind of think of it as an eyeball because it looks like it has an eyeball part and a white part of your eye. That has to be 0.05. So notice it's already got 0.04 or 1, so we're going to need 0.04. Okay, so notice that adds to the 0.05. And then we have our A1 and A3, do a different color. A1 and A3 is also 0.05. So here's A1 intersect with A3. So since it also includes the 0.01, we're going to have 0.04. That's just a coincidence that it's the same. 0.04 is going to be on that piece. And then we have the last intersection of 2 sets, which I'm going to draw in the blue. That's A1 intersect A2. And notice that from my directions adds to 0.15. So this would have to be 0.14. Okay. Now, once you get those pieces, you can look at the individual circles. Okay. So like I said, working from the inside out, I'm going to bring up my calculator and I'm going to do a full screen share so you can see the calculator. So we've got A1 is supposed to be 0.22. So 0.22, and we're going to subtract the 3 pieces that are in part of A1. So that's a 0.14. Oops, hit subtract. And a 0.01 and a 0.04. So there's only 0.03 left over in that outside portion of A1. So notice this whole circle now adds to 0.22. Then we have 0.25 is for the whole circle A2. So I've got my 0.25 minus 0.14 minus 0.01 minus 0.04. Again, that's the same as the last one because they both ended up having that 0.05 for the intersections. But this one's going to have 0.06 left over on the outside. And then A3 was 0.28. Now, A3 is intersecting with these 3 parts, the 0.04, 0.01, and 0.04. So 0.28 minus 0.04 minus 0.01 minus 0.04. There's still going to be 0.19 left in this piece. Okay. Now we're not done because we need to figure out what probability is left on the outside of all 3 circles. And that's found by if we add up all these little areas, these probabilities, and then subtract from 1, because remember that's like the whole universe is 100% or 1, we'll be able to find the outside. So 0.03 plus 0.14 plus 0.06 plus 0.04 plus 0.01 plus 0.04 plus 0.19. All three circles added up to a total of 0.51. So I'm just writing that as a note for myself. Okay, so we're going to do 1 minus 0.51. That's 0.49. So there's 49% chance that none of them got awarded bids. Okay. So we needed this to be able to answer the numerical parts of each section. So we didn't really need it to answer the notation part. A1 union A2 means you're either in 1 or 2, but you could be in both of those because you could be in that overlap. So it's going to be the either 1 or 2 or both. If we add together these, so you're just adding A1 circle and A2. So that's 1, 2, 3, 4, 5, 6 different little areas. Let's do that on our calculator. 0.03 plus 0.14 plus 0.06 plus 0.04 plus 0.01 plus 0.04. That is a 0.32. So the probability that we are in either A1 or A2 or possibly both at the same time, because it's including either or, one or both, that's 0.32 or 32%. Now, this next one, they give you a hint on because this is something called De Morgan's Law. De Morgan's Law says if you have a union or an intersection, doesn't matter which one it is in here, and its whole thing is being complemented, it's not distributive property, but some people think of it like that. You are saying you complement both individual sets, you make them the opposite of what they are, and we change that from, if it's a union, it changes to an intersection. If it's an intersection, it would change to a union. The reason that's helpful is because it actually helps us because we already did part A. So they're saying if you think of De Morgan's Law, A1 complement, which means not A1, just in case you didn't know from previous videos and your readings, not A1 means anything outside of circle A1. So that'd be that 0.06, 0.04, 0.19, 0.49. Those four areas are outside of A1. So not A1 intersect with not A2 is the same thing as saying A1 union A2, because we change both of these from knots to originals, and we change this to a union, and then we complement the whole group. Now, why is that helpful? Because A1 union A2 was all those that we just added up. That added up to 0.32. So since we already did that, we already know the probability of that union A2. If we just subtract that, we'll have the complement. So 1 minus 0.32 is 0.68. Okay, now I will show you that I could have done that from the original setup. I'll use a highlighter to help you see this. So not A1 would be this, 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 and this. Okay, so just kind of those are the areas that are not in A1. Not A2 would be this, 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 and this. Notice we would have been intersecting those two things, which means we are only looking for where the colors overlapped. So they had to have it in common. So that'd be the 0.19 plus the 0.49, which is 0.68. So that's another way you could have gotten it instead of using De Morgan's Law. So just be aware there's sometimes more than one way to figure out the answer to these pieces. Okay, so let's look at my next one, part C. We're unioning all the circles. Okay, so we already did that. That was when we added all the circles together. So the union of all three. Oh, I forgot to put the choice on this one. Sorry. Let's go back to part B for a second. This was, if we think about it this way, as a union that's being complemented, we are awarding neither 1 nor 2. We're doing the opposite of the union, essentially. So neither 1 nor 2. If you're using the union of all three, there's a lot of different ways you could state that. It'd be either I'm in 1 or 2 or 3 or 1 and 2 or 2 and 3 and 1 and 3 or all three. There's a lot of different things that includes because there's all these different little sub areas here. So the best way to say that is we're just saying at least one. That means one project or 2 projects or 3 projects. So it could be either of these little individual areas. So awarded at least one of these projects. And that was the big addition of all 3 circles. So that was that 0.51. You could double check that by adding those pieces again. Okay, let's look at this one. This is the not A1 intersect with not A2 intersect with not A3. So this means we're awarding none of the 3 projects. Again, if you wanted to color code and see this, I'll help you see it that it is really just the outside area. Not A1 is these 4. Not A2 is going to be this one, this one, this one, and this one. And then not A3 would be this one, this one, this one, and this one. Notice the only place that got all three highlights was the 0.49. Okay, so if you're intersecting, remember you have to have all three are in agreement at that place. So it's in common. Let me undo all of the color coding. So it is just the 0.49. So it's none of the projects were awarded, which is our outside piece for 0.49. Okay. Now these last two are going to be kind of combinations. You have some things that are complemented and some that are not. So I'm going to use De Morgan's Law because it makes it a little easier. But you could highlight each piece individually and then intersect. So you're only looking for where all of your highlighted colors are in common for this one. So again, I might still show you that after we do this by De Morgan's Law. So I'm going to take these two since they're both complemented, and I'm going to switch them using De Morgan's Law. So it becomes a union of just the regular sets, and then we complement the outside, and then we're going to intersect that with A3. Okay, so A1 union A2, just to show you this, that is all of circle A1 and all of circle A2. So the complement of that, the opposite of that would be 0.19 and 0.149. Then we're going to have to highlight all of A3. So that's this piece, this piece, this piece, and this piece. Now we are intersecting those two things. If you go back and look down at our, let me get this back to a pen. Not wanting to scroll down. There we go. We're intersecting that complemented union with the A3. So we're looking for where the pink and yellow overlap, which was 0.19. So that's going to be our answer, is the 0.19. Now, I could have done not A1, not A2, and then, so I will show it another way. Oops, I'll have to go back and write that in, but let me do away with all the highlighting, just so you can see that I didn't have to use De Morgan's Law. I could have done not A1, which is this, 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 and this. I would have done not A2, which was this, 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 and this. And then I would have done A3. It wasn't a complement of A3, it was just A3. So that's this, 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 and this. And you notice, again, 0.19 is the only place that I highlighted in all three. So since I was intersecting, that would have been the answer, okay? But I liked using De Morgan's Law because then I didn't have to look at each individual piece. I was able to just say, not the union of A1 and A2. So that was this and this. And then I was doing A3 as its regular self. So I had to highlight all of those. And it was clear to me that the 0.19 was the intersection. Now I'm going to leave that picture actually, because I think it's going to help us on the last one. Let me fill this back in with the 0.19. Okay, so this one I can again use De Morgan's Law if I want. So I can say that that A1 becomes a union with A2 and then intersect on the, or complement on the outside. So change the symbol to this, and then both of these change to their originals, and you put the complement on the outside. But this time I'm unioning it with A3. So notice this is almost identical to this, except we are unioning. So let's read to see if we can, I didn't make the choice on this one, sorry. This one was awarding 3, because you were giving someone 3, but not 1 or 2. So because those were complemented. And but means intersect. So, and then this one, this would be, let's see. Neither 1 and 2 or 3. Yeah, so it's going to be this one right here. So awarded neither of the 1 and 2. So that part, neither of those two. And award, or, because we're doing a union with that, we awarded 3. Okay, so let's go up here and look. So if you're doing an or, you're actually adding all of the highlighted pieces. We just don't add the 0.19 twice because it's already counted once. So we're adding this region, this region, this region, this region, and this region, okay? So let's get our calculator. So since we're doing an or this time instead of an intersection with the A3, we're going to include all those pieces. That gives us 0.77. All right, and that's the end of number 4.